Really harder again when we go on to number 7. This time we've got Charlotte playing the game. She's got a fair dice. If the dice lands on 1 or 2, then she scores 1 point. If it lands on 3, 4 or 5, she scores 2 points. Or if it lands on 6, she scores 3 points. And she rolls the dice twice. So again, you could use a tree diagram for this, or you could just use what you know about probability and an OR rules. Okay, so the first question is, what's the probability she will have a total score of 4 points? Okay, well, there's 3 different amounts of points she could get. She could get 1 point, she could get 2, or she could get 3. The probability she gets 1 point is 2 things out of a possible 6 outcomes, okay? 2 out of the 6 faces of the dice give her 1 point. 3 out of the possible 6 give her 2 points, and only 1 out of the 6 give her 3 points. She then rolls again, and the same options are available to her. So we've got 1, 2, or 3. Just doing a really rough tree diagram here just to help me understand it. Doesn't have to be that neat. Okay, I've not written the probabilities on here either because I know what I'm going to do. I just want to add up and find out which roots give me 4 points. So this one only gives me 2 points, so that's no good. This one gives me 3 points in total. This one gives me 4. Okay, so I'll come back to that one after. Okay, if we get a 2 the first time, then a 1, we've only got 3 points. 2 and a 2 gives us 4 points, so I'll add that one up in a minute. 2 and a 3 gives us 5 points. A 3 and a 1 gives us 4 again. A 3 and a 2 gives us 5. And a 3 and a 3 gives us 6. So I need to work out this plus this plus this. So the probability of getting a 1 and a 3 is 2/6 times 1/6. So a 1 and a 3. 2/6 times 1/6 is 2/36. Okay. Or, and if you remember or, we use an add. Actually, I'll just write the word or there. We could get a 2 and a 2. And the probability of that happening is 3/6 times 3/6. So 9/36. Or we could get a 3 and a 1. And that's 1/6 times 2/6. So again, 2/36. With all probabilities, we add them together. Okay, so we've got 13 over 36 in total. On part B, we've got Charlotte starting again. This time she's rolling the dice 3 times, so as you know, this would be too big for a tree diagram, really. What is the probability she'll have a total score of 4 points now? Okay, well, if I think about the ways that she could get 4 points, we could have a 1, a 1, and a 2. That would give us 4 points. Or we could have a 1, a 2, or a 1. Or we could have a 2, a 1, and a 1. We can never get 3 points because the lowest amount of points she could score is 1. So if she got subsequent 1s, the next two rolls, that would be 5 points. It would be too much. So this is actually the only 3 ways she could get 4 points. And we just need to work out the probability of those ways. So the probability of getting a 1, a 1, and a 2 is 2/6 times 2/6 times 3/6. Okay, so that's 12 over 6 times 6 is 36, times 6 is 216. Okay, probability of getting a 1, a 2, and a 1 is 2/6 times 3/6 times 2/6, which actually gives us the same number we got over here. 2 times 2 times 3 is the same as doing 2 times 3 times 2. So that also gives us 12 out of 216. And the last one, you won't be surprised to find that that also gives us the same, because these probabilities aren't changing. So because we could have any of those options, we add them together and we get 36 out of 216. And if you're interested, the chance of that happening, if we simplify that down, it's actually 1/6, less of a chance of that happening now that there's 3 roles than there was when there were 2 roles. Okay, we were closer to a half or a third there. We're only on a 1/6 now.